For the question D, we can get it is the gamma distributions, and we can get A lambda equal to this, and the var lambda equal to this. Then we
wait, are you doing question D?
Yes, UVR will show the question ABC.
What he's sorry, can you give him to show first? Because I thought you're doing question ABC. Because if not, it doesn't make sense.
I'm not prepared the question. The answer.
I mean, you
not very good for this.
No, I mean Yue is here.
No.
I mean he's here, so you don't have to share.
Oh, okay.
I think we ask the Yue to do first.
Yes.
Okay. Wait. All right. Okay, so you can you stop sharing? Is it you, Yue? Oh, is it? Okay. I'm thinking kenapa berpusing-pusing. Okay, wait. No. I close. Okay. Yeah, I mean okay.
So we want okay. Now I think it's okay. Yeah. Sorry guys, sorry. First time. And so after some calculation, we get the posterior lambda will be gamma distributed with alpha plus n and beta plus sum of y. To get the posterior mean in terms of paraben and the maximum likelihood estimator, we need to specify the mean of posterior, which is alpha plus n divided by beta plus sum of y, and we can split the denominator to two parts and do some magics, and afterwards you can find you let the w equals to beta over beta plus sum of y. You should get the following forms as requested by the questions. Okay. Now it's good. Okay. That's the question A. So for B, we would like to find the Jeffrey prior and express as a member of the conjugate family. So using the Fisher's informations, we need to do double differentiations on top of the log likelihood. We should get a form of the negative n over lambda square. By substituting into by getting the expected values, we get the Fisher's information of n over lambda square. So the value in the third step will be getting a square root of it. So it will be a proportional of lambda power of -1. So from this we can it belongs to gamma 0 distributed. So afterwards we just compute the posterior distributions, which just it is gamma n and sum of y distributed. Move on to see, we want to do a transformations of the prior lambda in the terms of phi. So and to show it is a uniform prior for phi. So firstly, we compute the inverse G functions in terms of phi. So we get lambda equals to exponential 5, and we compute the first derivative. We get the Jacobian matrix, and we substitute into the prior function in terms of 5, and we should get proportional values equals to 1. So we can see it is a constant value, it is a uniform prior. Also, we need to demonstrate the property of invariance to the reparameterization. I just copied from the lecture notes. Basically, it's to get everything sort of in terms of phi, and finally, there's a part of d lambda d5 square which can be pulled out from the equations, and it is a constant in terms of phi, so it's proportional, which means that it has the invariant properties.
You're supposed to show it correctly.
Mm-hmm.
Meaning you have to find the log likelihood. You have to find the likelihood.
Oh, okay.
I mean, of course, by formula, everyone can do it, but you have to actually find the likelihood, find the log likelihood, and then show using exact equation. Yeah.
Okay.
Okay. Right. All right.
I pass to go for the next question.
All right. Okay, this is all right. So, Ian, Bowen, you can share yours now.
Yes. Can you see my screen, Doctor?
Sorry.
How about now?
Okay. Ian, are you?
Yes. Can you hear me? Doctor, can you hear me? Hello?
Okay, I can hear you.
Okay, can you see my screen?
Yes, we can see your screen.
Okay. And for the question D, we can see that it is gamma distributions, and we can get E lambda and var lambda. Then for the computation of variations, we can get it equal to this. Then we consider the Posterior distribution first. For the first graph, we see it from lambda to gamma alpha 1 beta 1. We can get alpha 1 equal to 11 and beta 1 equal to 18.8. For the same way, we can get the second group, alpha 2 equal to 4 and beta 2 is equal to 14.4. Then we see the posterior distributions. We know from the questions, we know n equal to 5 and we can get the y equal to 48.5. So for the first group, we can find the gamma alpha 1 at n beta 1 at y equal to gamma 16 and 136.5. The posterior mean equal to 0.1172 and versus equal to 0.86. For the same way, we can get the second group. We can get the posterior mean equal to 0.0973 and the versus equal to 0.00105. For the lambda smaller than 0.1, first group, we can use R, get the P gamma 0.1, 16, 116, 6.5 equal to 0.2965. And for the second group, we can get it equal to this. For the questions, we should to think the part B. We can get the posterior mean equal to this. Now, then we let C equal to then we let C equal to this, and then we can get the posterior mean equal to C point. We can get the C equal to this. For the first group, we can find the C1 equal to 0.6447 and the C2 equal to 0.4757. Then we can get the number is close to the second group. For the question E, although the power of the second group is closer to the posterior, the variance of the second is also large, so it cannot simply be said that the second group is more accurate. We can describe the number of the samples, and the larger the number, the more accurate the results. That's all.
Okay, thank you.
Okay, thank you, Doctor.
I think, all right, so I think that all right, the point here is that if we use this one, right, if you have more data, obviously the data will dominate, right? So if you have more data, then the N and the S will actually become bigger and more dominant, right? So then it will actually get closer to the reference prior, sorry, the NS part, right? Part 3, right? Because it will be closer to the reference prior because that one is the non-informative prior, right? So your answer will get closer to the one with the reference prior as your data becomes larger. I mean, as you have more data, sorry. Okay, so meaning that your prior will become less important lah. Your data will dominate more.
Yes, Doctor.
Oh, yeah. Okay, it's okay.
Okay, thank you.
Okay. Okay, what you say? The mean? No. I mean the estimate is closer to the MLE. The reference, the posterior will actually be closer to the posterior with the reference prior. Because if you see the distribution, right? If you see the distribution, then the posterior with the reference prior. Okay, I think I perasan dia dah share ke tadi. I can't see whether he shared or not. So if you look at the one with the reference prior, so actually the posterior is actually gamma and S. This is what I meant, right? Meaning that the distribution will be closer to this distribution, the one with the reference prior. Not it goes to the prior, right? I mean the posterior will be closer to the posterior with the reference prior. So if the one with the conjugate family, right, is actually, let me see, is actually gamma, you will be n plus alpha, right? And then you have S plus beta. Right. So if you have a prior, then you have the alpha and beta. But if you use a reference prior, there's no, because remember, right? I think the part with just now is the part for the question B is supposed to say that if you have a reference prior, right? The reference prior is gamma 00, right? Gamma 00, right? The reference prior is gamma 00, right? I mean, approximately 0.0. So the aim here is you don't have to find the posterior, because the gamma 00 means alpha 0, beta 0, so you get an S. That's it. Right, so the aim here is you have to show that the reference prior is approximately gamma 00, meaning your alpha is 0, beta is 0. So if you put in alpha 0, beta 0 here, you get an S. That's it. Okay. So this means that as your N and S gets more data, you have N and S get larger, then from here it will be more closer to the one with the reference prior, this posterior lah. Okay. So that's what I meant. Right. Okay. So then, we have the next one, which is question 2. I can't remember. URI 2, yes. Okay.
Okay.
Right.
Hello, can you see my screen?
Yes, we can see your screen.
Okay. My question is 2. Suppose that yi given theta follows uniform 0 theta distribution. I equal 1 to n, where theta is an unknown parameter to be estimated. This is A. Show that m equal max y is a sufficient statistic for theta for y. First, let's n equal 1, 2, 3, 4, 5, and so on be the set of positive integers, and let n theta equal 1 to theta. Then the round probability of y1 to yn is this function. We let my equal max yi, so we can see that this function. Thus we have the factorization. Just this. This make 2 function. This is the first one. This is 2. The first factor depends on y1 to yn only through the value of my equal to max y, and the second factor does not depend on theta. By the factorization theorem, m equal max y is a sufficient statistic for theta. This is the A. This is my question B. You can see that shows that the conjugate prior distribution is a Pareto distribution, where theta follows Pareto AB distribution. This is per theta equal to this. From A, we can get the joint probability is this function. So likelihood function is this, which give Pareto distribution with alpha equal to n minus 1 beta 0. Because I don't know what this number is, so I use beta 0 replace it. Loss the prior density p theta is this. Give the posterior distribution follow is this, so we can get this function, which is a Pareto distribution with alpha equal to n at a beta 1. This is the C. Consider the transformation phi equal to log theta, assuming a constant superior for phi on 0 to endless. Find the equivalent superior for theta and the corresponding posterior distribution. We can see phi equal g theta equal log theta. So we can get these two functions. And then we can get p phi is this. Because p phi is equal to say for this word, and also equal to this for this function. So we can get this, and then we have this. So the equivalent superior for theta is uniform distribution 0 to theta. The corresponding posterior distribution is this, which is a Pareto distribution with alpha equal beta 2. Hello, doctor.
Yes, I'm listening. Yes.
Okay, that's all.
Okay, thank you. Yeah, there is a correction. Okay, the correction is because she missed the indicator function, because the Pareto is okay, okay. This is part where I have to share my this. You can see me on screen. I'm menggambarkan diri. Alright. Focus on the screen. Focus on the board, not me. Although I'm in the middle of the board. You can see, right? Actually, the board. Alright. I mean, in the thing, it's not here. Okay, right. Okay. Alright. So I think the thing here. Okay. So first, I think you already did a good job lah to because this is actually quite a hard question, right? And I think the problem is because the limit, right? Because whenever we had the question before, the limit was actually a constant, right? So that was the one thing. But now the limit actually depends on your parameter. So that becomes like a big problem. Okay, so the part one here is actually the part where you have to define the problem such that your parameter is inside your PDF. I mean, the limit. Okay, so I think the first part here is when you do your join PDF, right? I think she did up to, it was halfway, to the end was quite correct. I think the this part here is when she has a problem is you have an indicator, right? And then M is your function of the maximum, right? Okay, so here means that I put in my join PDF is 1/Tn, and then you have the multiple of the indicator, right, of your yi. So this means that if your maximum is inside the limit, then everything is inside the limit already lah, right? So this means that I can just change the multiple of the I indicator, that one, to this part, indicator of as long as the maximum is inside the limit, then everything, all the y will be inside the limit. Okay, so then I change into this part. So this is the likelihood. So meaning that this is also when you want to show that it's a sufficient statistic, you can use this one because it's a function of theta and a function of the data, right? So they are separate. Okay, right. And then, so for B, because you want to show that it's a Pareto, so this is your likelihood. I mean, if you put the likelihood, then it will be proportional to this function. Okay, and then because your theta is inside the limit, so you cannot get rid of this indicator function. it must be, I think this is the part where you had problem, because this indicator function must be inside, must be in the limit. Okay, right. So but now, because your theta is your parameter, so what happened is we have to rewrite the limit. Okay, so basically it's a trick question now, right? So if you have your y, then theta is a constant, right? So this y is your n is between 0 and theta. But if your theta is your parameter and y is your constant, then you can actually rewrite your limit as this. Right? So meaning that you have your theta, as long as your theta is bigger than your maximum, then your data will be inside less than your theta. This is like playing around lah. Okay, making your life harder. Okay, right? So then you have your likelihood is this, right? And then you have your prior. Prior is theta, right? But then again, you have to rewrite your prior. Right, so it's theta A plus 1. So this is where your theta, so your theta bigger equal to B, right? So okay, this is, where is your prior? Oh, it's B, yeah, it's B infinity theta. Okay, so then if you want to find your posterior, okay, right? Okay, then you have to multiply both of these, right? Then you have, okay, and here, AB is a constant. So, no, bye-bye, AB. So you have theta, only the theta part remains, right? The AB, so you have your theta power n, a, and 1. Okay, this again, okay, so now you have your M and your B, right? But then the problem here is to make sure your theta is bigger than both, meaning theta must be bigger than both M and B, right? So then it will be the maximum of your M and your B theta. Okay, so meaning that if your maximum, if your theta is bigger than the maximum of both, then the theta will be bigger than M, theta will be bigger than B. All right. Okay, so this means that your posterior is actually a Pareto. So if you look at the Pareto, right? So that is a Pareto. This is a Pareto AB, and this is a Pareto N. What was it? I think Pareto N, I think. Oh, that's the same. Okay, so anyway, this is Pareto AB, right? This one, right? So this is actually a Pareto N plus A. So because this is a theta A plus 1, so this is a theta N plus A plus 1. So this is N plus A, right? Theta N above Pareto theta N plus A, and then this is a maximum of M. So it's a Pareto, so quite a different parameter. Okay, right. So for C, okay, so for C, meaning that if you use the transformation, then you have to put in the limit there, right? So, okay, all right, you can do the transformation because it's not, sorry, 9 o'clock, so to make sure you're on time. So this is the part B. So for C, so the aim here is after transformation, then this one you can try on your own. Your theta will be a Pareto also. Pareto. The parameter is N, and then maximum of M and 1. Okay, after transformation. Okay, so based on this B part, then the C part you have to do transformation, and then you multiply with your likelihood, right? And so you have your likelihood and your prior, then you should show that the theta has the Pareto distribution with parameter n and maximum of M1. Okay, let me try it on lah. Okay, all right. Okay, so okay, close the camera. I'll still show you my face. Okay, right. So then the question 3,
Okay.
right?
Okay.
Okay, jadi you can share your screen now.
So X given by mu is the normal distribution with mean mu and the variance phi, and Y given by mu delta is the normal distribution with mean mu plus delta and the variance phi. Since X and Y are conditionally independent, so the joint distribution of X and Y given by mu and delta is the product of X and Y. So yeah, can be right as this. And B, consider the joint prior distribution to find the joint posterior distribution. So from A, we can get the likelihood just ignoring the X squared and the Y squared. And the joint posterior distribution is a product of likelihood and the prior. So here is the density function of the joint posterior distribution. And because of the mu delta term, so the joint posterior distribution cannot be written as the proportional of mu given by xy in delta given by xy. So they are not independent. Yeah, that's all.
Okay, thank you. Right.
Okay.
Okay, all right. Okay, so then next is Jiao Hao Cheng. Jiao Hao. Jiao, are you speaking? I cannot hear your voice.
Hello, doctor.
Oh, okay. I thought I closed the. Okay.
Microphone doesn't work. Oh, it's not my microphone doesn't work, so there's no sound.
Wait, what is this? Right. Okay. All right. Wait. Okay. All right. Yeah. Okay. Yeah. Okay. All right. So this is playing with the normal. Playing with the normal again, right? Okay. D. All right. D. There's something wrong with D. Okay. D. I think you did something. There's something not correct with D. Are you talking? Jerry, I cannot hear your voice again. I cannot hear your voice. Sorry, doctor, yeah? Okay, right, it's okay, right. Oh, all right, okay. Okay, so can you share your screen again just now? Oh, you are talking. You cannot reveal your voice, right? Okay, I think I don't know what happened, your mic or something. Just now you can hear, right? Then suddenly it disappear. Okay, okay, it's okay. Can you leave here? Leave it here. That's all right. It's okay. I can. You can hear. Okay. All right, all right. It's okay. Can you just leave it there just now at question D? Okay, all right. So I want to explain. Okay, I want to explain because there's something wrong. Let me see. Okay. Z mu x mu y. Okay. Right. 3 mu. Okay. All right. Okay. So the thing here is for question C, she got it correct, but for question D, there's something going on, right? So for question D, I mean for question D, let me write this part. I cannot write everything because you know it's long. I know it's long. Also, okay. I think you have to open the first line is correct, but then when you open the bracket, then become. I mean it's nasty lah. It's nasty normal, right? Let me just write. So okay. Somebody asking me because you need to okay. So in theory, we need the full join. We need the full PDF, right? But because here they are actually normal, so actually a lot of normal what call it? A lot of normal function you can normal also. So this is also a normal distribution. Okay, so that's why you can actually use just proportional just for this case because it's a normal distribution. Okay, so for the one that I did just now is correct because you have the z and then you have the mu at the joint posterior, right? So the first line is correct. So I think when she opened the bracket, there's something going on because it does not become like that. Okay, so as a practice, so the answer would be 2x minus y. The mean is 2x minus y and the variance is 6 phi. Wait, phi is yeah. So after a long meaning if you look at my answer, is this long. Okay, so from the top, the ujung tu, that's the answer. Okay, so you can imagine lah, right? So how many lines you need? You can see. I think you cannot see. You cannot see at the screen. It's like the reverse, right? Reverse camera. Okay, so you need like 1, 2, 3, 4, 5, 6, 7, 8, 9 lines, 9 proportional lines to actually get the answer. I mean, roughly. Okay, so you have to. I think when you open the bracket just now, there's something going on because I think the problem here is because you need to get the normal kernel, right? Okay, so you need to know. So it's a lot of math manipulation lah, right? So I don't know where to share to. Right. think where to share to actually because it's long. Wait, let me see. Yeah, maybe I'll try. Maybe I can share that actually. Take a photo later lah. Because it's long. even I think it's long. Okay. All right. Sorry. Even I think it's long. All right. So I know it's nasty, right? What is the 39 line? So pity. Judging is called. Yeah, I know. Right. I understand your pain. Yeah. So it is. Yeah, 29 lines. Yeah. Sorry. Okay, so anyway, no, I think when she did the I think up to the third line is actually correct. But after that, when she's trying to simplify it, then it becomes a bit weird because you need to get the normal kernel, right? Sorry, you need to get the normal kernel because you want to integrate out the mu and the delta, right? So you need to get out the normal. Sorry, that's not normal kernel, normal PDF actually. The one we need that you have. Okay, so kesian dia ternampak. Okay, so what happened here is when you have the proportional, right? You need to integrate out the mu. So you need to get like something over the variance whatever, right? And then you have to get like mu minus something square, right? Then d mu like this, right? Then only you can actually integrate out your mu. Okay, I think this is part where maybe that's the part where she did wrong. And then also the same with delta, right? Delta you have blah 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 blah. Delta minus the mean and then square, right? So this is part, yeah. And then only you can integrate out the mu and delta. And this is where you know you have at least, and that part is 3 lines because now you have the mu, the delta, and the leftover. Right? Okay. So don't worry, I will. Yeah, I think I probably have to share it. I will share with you later. Okay. Right. So the right. Okay. So anyway, that's it. I'll stop now. Okay.